Hello everybody and welcome to Statistically Speaking. Today I'm going to start a series on matrices. Now, matrices are something that's very commonly used in math by mathematicians, but it's also commonly used for statisticians and probably a lot of other fields too. But this series is going to be based around a statistics view. So I'm not going to go into depth about everything about matrices. I'm just going to go into the things that is commonly used for statisticians. And some of these are the basis that everyone that learns about matrices learn about, but some are more specific ones that have specific uses. But first start with, what are matrices? Well, the singular is matrix. And it's not about the movies Matrix, though I wouldn't be surprised if the movies use this concept of matrices in some way. But I haven't read up on that, so I don't know for sure, but it would be quite possible. So then, what is a matrix? Well, I'm not very sure on how to explain it in words. I think the easiest way is to show with examples. So let's take a look at a few examples. So here we have three matrices. One thing that you might notice is that all of these have this way of showing, like here is its start and here is its end. That's usually how we denote a matrix. We have those square parentheses kind of situation. And inside of this, we have the number of rows and the number of columns, and then with what would be there. In these examples, we have numbers, but it could very well be letters that represent numbers. Like we could have A11, A12, A21, A22. And there is a specific reason why I chose to write 1, 1, 1, 2, 2, 1, 2, 2. I could just easily have written, let's say, X, Y, Z, and let's say K, letters. I could have written it like that, but I chose to write it with A. And that is one of the most common ways to denote a matrix. A matrix is very commonly denoted with a letter. Let's say, for example, this matrix we would denote as A, and A is equal to this, and this is the matrix, and then we have what's inside of A. However, when we have matrices, the letters that we denote it with, we usually use bold letters. So, in this case, it would be a bold A to denote that it is in fact a matrix and not just one number. But these inside of this, those would be normal, not bolded. So that is how we would denote it. And like you see also, I wrote 1, 1, 1, 2, 2, 1, 2, 2. That is because we usually, these numbers just denote which spot in the matrix are we looking at. So this 1, 1, it's the first row and the first column. 1, 2, first row and second column. 2, 1, second row, first column, and 2, 2, second row and second column. And this can of course be lengthened to whatever number you want to put at the end. So let's say we would have n columns and number of rows, let's say we would have m rows. And this is usually how we denote dimensions of a matrix. Now, what the dimension is simply how many rows and how many columns. And we always put the number of rows first and then the number of columns. So, in this case, we would have a 2 by 2 matrix. In this case, we have 2 rows and we have 3 columns. In this next case, we have 3 rows and 1 column. And in this last one, once again, we have a 2 by 2. So, we have these different situations. Now, when can we say that a matrix is equal to another matrix? Well, it needs to fulfill a few things. First off, it must have the same dimensions. So, let's move to the side and let's say we have this matrix. This 2 by 2 with just ones. So, let's say we make another matrix that has 1, 1, 1, 1, 1, 1. They need to line up to be precise. So, is these two equal to each other? Well, it's still just a matrix full of ones. Would that be the same? No, because this is a 2 by 3. They are not equal to each other. These two are not equal. And the same is true, let's say if we would have zeros here. Because this part that has non-zeros are still the same, but because we have those zeros, it isn't the same anymore. And the same would be true if we would do 1, 1, 1, 1, 0, 0, zeros at the bottom. It would still not be the same. This is a 3 by 2. It wouldn't be the same as this either. They are not equal. For it to be equal, it needs to be the same. So the only that is equal to this would be 1, 1, 1, 1. That's the only one that is equal. So that is pretty self-explanatory. For it to be equal, it needs to be equal. Like all the way equal. But so far, we've only looked at just random matrices with no context. But let's give it some context. Let's have an example that isn't a matrix and make it into a matrix. So, let's say we have 2x plus 2y is equal to 12. And we have 3x plus 4y is equal to 22. So this is a very common math problem. You know what x and y together will become in 2 different scenarios. You could have more than just x and y, you could have a z and so on. But just to have an example, this is what we have. I could use normal math rules to figure out what x and y will be. However, you could also do it with matrices. I'm not going to go through in this video how you'd calculate it. Now we're just going to put it up as a matrix to see how it would look. And then in the next video, I will go through how to actually calculate it. So, there's multiple ways we could write this matrix. We could write it as one matrix or multiple matrices, but it would be the same in the end. So, let's start with just one matrix. How would this look? So, first off, the first row, we have 2 to 12. We don't need to put in x and y, because that is by itself self-explanatory in a matrix. And then we put in the second row, so we have 3, 4, and 22. Now we could leave it like this, but a very common thing to do is just to put a line here to show something that symbolizes this equal sign. Because this plus, that is also self-explanatory in this. If we would have a minus, let's say we would have a -4 here, we would just put -4 instead here. But in this case, we only have plus, so that is what we're going to use here. This matrix has a specific name. It is called Augmented matrix. And that's simply what we have. We have this matrix is equal to these numbers, kind of thing. But like I said, we can write it in another way also. So let's say we want to have these as one matrix and this as another. So we want this matrix is equal to this matrix, kind of thing. Then we could write it as, so let's say we have 2 and 2 and 3 and 4. So the same thing as before, but now we close that matrix. That is the matrix. And let's say we want to be very clear that it's x and y. Then we could write just x and y. Now, don't be confused. This doesn't mean that this row is equal to x and this row is equal to y. You will see that in a future video when we go through how to calculate multiplications with matrices, because it's not as straightforward as you would probably wish it were, but it is logical once you get a hang of it. But you have this, and this is then equal to 12 and 22. So these things means the same thing. Both of them means these equations. And how we would denote this? Well, common ways to denote. Let's say this first matrix. Let's denote it with a B. And like I said, it needs to be bold. I might not do it in every video with this bolding, just because it takes time, but to be accurate, it needs to be bold. This other matrix, it is commonly denoted as, let's call this first part of this A. So we have A, bold A. And then we have this matrix with x and y. So we could then note that as x, and we just put this little symbol above it, like a little arrow. That just means it's a vector. I will go through what a vector is later, but it's simply just a matrix that only has one row or one column. So in this case, it only has one column. And if you denote it like this, you don't need to bold the x. You could do a bold x. That would be fine, but this is a very common way to denote this. So from here, we could calculate from this what x and y would be. We could also see from this if it would have 0 solutions or infinite solution, or if it has one solution. But like I said, I will do that in the next video. This video is just to make you see what is a matrix even. So I hope that helped, and you have a little clearer view of what a matrix is.